How long after the Earth formed did life appear on it? What did the oldest forms of life on Earth, the so-called stromatolites, look like? And what is the so-called Cambrian explosion? We will try to answer these and similar questions in today's episode of the series Secrets of Genes, in which I welcome you. My name is Edward Kejnovsky and I work as a geneticist at the Academy of Sciences of the Czech Republic. No matter how bold the idea of panspermia may seem, it would quite nicely explain the fact that life appeared on Earth suspiciously quickly. Let us recall that the Earth formed 4.5 billion years ago, and for the first 500 million years, it was undoubtedly sterile due to high temperatures. The absence of liquid water, high radioactivity, and frequent impacts of large meteorites. But as early as 3.8 billion years ago, we have evidence of the oldest forms of life in the form of so-called stromatolites. It is remarkable that at the very time life emerged, our planet was likely undergoing a period of heavy meteorite bombardment, dated to between 4.1 and 3.8 billion years ago, caused by a disturbance in the cosmic balance in the region of Jupiter. In this context, the recent experiments by Czech scientists are remarkable. They irradiated formamide, a simple organic compound likely present in the shallow lagoons of ancient Earth, with a laser. We discussed this in one of the previous episodes, and they managed to obtain all 4 bases that make up RNA molecules. The temperature in the sample reached 4,200 degrees Celsius, which simulated the high temperatures generated during meteorite impacts. So meteorites could not only have brought life to Earth, but could have directly caused its origin on our planet. But let's return to stromatolites. They represent strange, fossilized formations that are believed to have been created by the activity of living organisms. Stromatolites are loaf-shaped structures several meters in size. They are an ecosystem composed of several layers of different types of organisms. At the bottom are anaerobic bacteria, while on the surface there is a growth zone formed by photosynthesizing cyanobacteria. Scientists have known about stromatolites for a long time, thanks to fossil discoveries. At the beginning of the 1960s of the 20th century, they discovered a community of living stromatolites in Shark Bay, Australia. The discovery was a big surprise for scientists, and today, Shark Bay is now a tourist attraction. Although the stromatolites in Shark Bay are only, in quotation marks, 2 to 3 billion years old, they are similar to much older stromatolites. We are touching an unbroken line of life, cell division, and reproduction of genetic information that has lasted for billions of years. And here we can see life in a form that may have existed soon after it first appeared on Earth. Life that evolved very, very slowly. So life had at most 200 million years to arise and develop into the form of unicellular organisms, similar to today's cyanobacteria, well-functioning biological factories in which the activities of thousands of molecules are coordinated, creating a web of various chemical interactions and the like. But about 200 million years is, from an evolutionary perspective, a very short period of time. And that's why many experts believe that life must have had some kind of help, and that help could have come from space. However, Mr. From Perm does not address the question of the origin of life. He merely shifts it elsewhere, outside the planet Earth. To the question of why life arose on Earth so quickly, almost immediately after its formation, there may be another answer, namely that the necessity for life to arise is somehow encoded in matter itself, and that the tendency toward life is an inherent property of matter, so whenever suitable conditions are met, life emerges very quickly. For the first 3 billion years, the only form of life were single-celled organisms, that is, for the majority of our planet's history. Single-celled bacteria lived without us for billions of years, while we wouldn't survive even a single day without them. And it was only less than a billion years ago that multicellular organisms appeared. Most of the basic forms and shapes of today's diverse life, especially animals, date back to about 530 million years ago, to the period known as the Cambrian explosion. It was a miraculous burst of complexity and design when life suddenly blossomed into a branching tree of all sorts of shapes, colors, and you could say, scents. However, it is possible, as recent discoveries suggest, that during the Cambrian explosion, there was simply an increase in the number of organisms forming hard shells, that is, organisms capable of fossilization, which is why we have tangible evidence of their existence. But the proliferation of living forms actually occurred at least 100 million years earlier, during the so-called Precambrian period known as the Ediacaran. Let's return once more to unicellular organisms, when life, over this long period, did not fundamentally change. Perhaps the greatest innovation during this long era was the invention of photosynthesis. Photosynthesis is a process in which organic compounds are formed from inorganic substances. During this process, water and carbon dioxide are consumed and oxygen is produced. It was only when photosynthetic organisms began to produce oxygen that the previously anoxic atmosphere, rich in methane, ammonia, and other gases, started to change. So photosynthesis was not invented by plants, but by bacteria, specifically cyanobacteria. Until then, anaerobic organisms lived on Earth, which did not use oxygen. For them, oxygen was actually highly toxic. In this way, cyanobacteria cleverly managed to wipe out many of their competitors. As cyanobacteria multiplied, the world began to fill with oxygen. The composition of the atmosphere gradually changed. Oxygen also combined with iron and formed iron oxides which settled out. We can say that for millions of years, the world literally rusted. So that's all for today. In the next episode, we'll talk about DNA, how genes work, and how genetic information is transferred from DNA through RNA to proteins. We'll describe the so-called central dogma of molecular biology. I'm really looking forward to seeing you, and if you happen to like my storytelling, I'd be grateful for a like. And if you want me to continue making episodes about genetics and evolution, hit subscribe, which will help these videos reach more people. I really appreciate your support. Thank you and bye-bye.